Hello everyone, in this video we are going to discuss solved problems from the page number 19. Already in the previous video I completed two problems, so let us start from the third problem. If f comma g are the functions from R to R are defined by f of x is equals to 0 if x is a q is nothing but rational. If x belongs to rational, f of x is equals to 1 if x does not belongs to rational, it means irrational number, and g of x is equals to minus 1 if x belongs to rational, and g of x is equals to 0 if x does not belongs to rational. Then find f of g of pi plus g of f of e. So first, here two terms are there. I am going to solve these two terms individually. First term, f of g of pi. Here this f of g of pi can be written as f of g of pi, which is equals to f of g of pi. Here we know very well that pi is an irrational number, so it means does not belongs to rational. So g of pi, in the g of x we need to check for which is not a rational. Here which is not a rational, so it means that value is 0. So in the place of g of pi, let us substitute 0. Next, f of 0. So in the f of x we need to check for g 0 is nothing but a rational, so in the rational numbers we need to check. So if x is a rational number, then the value is 0, so f of 0 value is 0. Next, g of f of e. This g of f of e can be written as g of f of e. So here g of f of e, this e is a Euler's constant, so it is not a rational number. So in f of x does not belongs to rational, the value is 1, so g of 1. Next, g of 1 value, in the g of x we need to check x is a rational number, so if it is a rational number, the value is minus 1, so g of 1 is minus 1. Now we want f of g of pi plus g of f of e, so that is f of g of pi plus g of f of e. F of g of pi value is 0 plus g of f of e value is minus 1, which is equals to 0 plus or minus 1. So 0 minus 1 minus 1. Let's move to the next question. Okay, the next question is, let set A is equals to 1, 2, 3 and set B is equals to ABC, set C is equals to PQR. If f is a function from A to B, G is a function from B to C, are defined by f is equals to 1 comma A, 2 comma C, 3 comma B, G is equals to A comma Q, B comma R and C comma P. Then show that f inverse of G inverse is equals to G of f whole inverse. So here the functions are given as ordered pairs, so writing inverse of it is very easy. So here function f is given as 1 comma A, 2 comma C, 3 comma B. Then we want f inverse, so f inverse is equals to, here simply of every ordered pair they give, just exchange the letters. Here this is x coordinate, this is y coordinate, so interchange these coordinates. 1 comma A will become A comma 1, 2 comma C will become C comma 2, 3 comma B will become B comma 3. Next, function G is equals to A comma Q, B comma R, C comma P. So now we want G inverse. So A comma Q will become Q comma A, B comma R will become R comma B, C comma P will become P comma C. So we got f inverse as well as G inverse. Now we need to find out f inverse of G inverse. F inverse of G inverse. It is very simple to calculate. Observe here. Here A comma 1 is there, here Q comma A is there. So simply avoid this same letters AA. So remaining what then? Here it is q, here it is, sorry, here it is 1, here it is q. Q is in the x coordinate place and 1 is in the y coordinates place. Just simply write q comma 1, x coordinate comma y coordinate. Next, here c comma 2 is there, here p comma c is there. So here c common elements remove. Next, here it is remaining 2, here it is remaining p. Here 2 is in the place of y coordinate and p is in the coordinate x coordinates place. So p comma 2. Next, here b comma 3, here r comma b, here b common elements we need to take off. So here x coordinate is r, here y coordinate is 3. So the last r comma 3. So we got the answer of f inverse of g inverse is equals to q comma 1, p comma 2 and r comma 3. Next, we need to find g of f whole inverse. Okay, now g of f whole inverse we want. So first I am going to find g of f value. This is also very easy. Observe this f function and g function one by one ordered pair we will observe now. Here 1 comma a, here a comma q, here common element is a. So if we remove that, remaining is 1 comma q, 1 comma q. Next, here c, common element if we remove, so remaining is 2 comma p. Next, here 3 comma b, here b comma r, so common element is b. If we remove it, we remains with 3 comma r. This is g of f. But what we want here, g of f whole inverse. So g of f whole inverse. Simply we are finding the inverse. So exchange the coordinates. 1 comma q, we can write it as q comma 1. 2 comma p will become p comma 2. 3 comma r will become r comma 3. So if we observe now f inverse of g inverse as well as g of f whole inverse. q comma 1, q comma 1, p comma 2, p comma 2, r comma 3, r comma 3. So we can say that f inverse of g inverse is equals to g of f whole inverse. Hence proved. Okay, let's check the next question. If f is a function from q to q is defined by f of x is equals to 5x plus 4 for all x belongs to q. Q is nothing but rational numbers. Then show that f is a bijection and find f inverse. So to show that f is a bijection, first we need to show that f is a 1 function as well as onto function. So f of x is equals to 5x plus 4. First I am going to show it is a 1 function. So x1 and x2 belongs to rational numbers. So f of x1 is equals to f of x2. So simply in the place of x, x1, in the place of x, x2. So 5x1 plus 4 is equals to 5x2 plus 4. Here plus 4 will get cancelled. So we remains with 5x1 is equals to 5x2. Here 5 cancel. So we left with x1 is equals to x2. So we got x1 is equals to x2. So we can conclude that it is a 1 function. Next, let us check whether it is onto function or not. F of x is equals to 5x plus 4. So take this f of x as y. So y is equals to 5x plus 4. Now find the x value from this. Take plus 4 to the left side. So we get y minus 4 is equals to 5x. Now we want x value. So take 5 also to the left side. So we get y minus 4 divided by 5 is equals to x. Now this x value we need to substitute in the given function. So 5x plus 4 is the function. So in the place of x, let us substitute this. 5 of, in the place of x, y minus 4 divided by 5 plus 4 as it is. Here 5 will get cancelled. So we remains with y minus 4 plus 4. Minus 4 plus 4 both will get cancelled. So we remains with y. So after substituting the x value in the given function, if we get the answer y, we can say that it is onto function. The given function is 1 function as well as onto function. So definitely it is a bijection. So show that f is a bijection completed. Next, and find f inverse. For the given function f of x is equals to 5x plus 4, he is asking to find the inverse. Let us check. Okay, the given function is f of x is equals to 5x plus 4. We need to find the inverse of it. So first make f of x is equals to y. So y is equals to 5x plus 4. Now interchange this x and y. In the place of y, write x. In the place of x, write y. X is equals to 5y plus 4. Now try to find the value of y. So plus 4 we take to the left side, it will become x minus 4 is equals to 5y. Now we want y value, so take 5 also to the left side. So we get x minus 4 divided by 5 is equals to y. So now in the place of y, write f inverse of x. So f inverse of x is equals to x minus 4 whole divided by 5. So inverse of the given function is x minus 4 divided by 5 for all x belongs to rational numbers. This already he only gave in the question itself. Okay, by this problem, solved problems completed. Now let us move to exercise 1 of B. Okay, before going to solve exercise 1 of B, till now if you didn't subscribe to my channel, subscribe. Okay, next is 1 of B. First question is, if f of x is equals to e power x and g of x is equals to log x base e, then show that f of g is equals to g of f and find f inverse and g inverse. So first let us show f of g is equals to g of f. First I am finding f of g. So here f of g is nothing but f of g of x. It also can be written as f of g of x. So now here f of, what is the value of g of x? G of x is log x base e. Log x base e. Now we need to find the value of f of log x base e. So if you observe the question clearly, f of x is given as e power x. F of x is given as e power x. We need to find the value of f of log x base e. So f of log x base e. So f of x is given, f of log x base e value is needed. So it means in the place of x we need to substitute log x base e. So e power log x base e. E power log x base e is nothing but x. Okay, now g of f value. G of f is the same as g of f of x. That also can be written as g of f of x. Here is equals to g of f of x value e power x. Okay, now if you observe in the question, g of x value is given as log x base e. Now we want g of e power x. So in the place of x we need to substitute e power x. Log, here x is there, so in the place of x, e power x base e as it is. Now this x will come to the front, so we will get x times log e base e. Log e base e value is 1, so which is equals to x. If we observe this LHS as well as this RHS, f of g of x value is x only, g of f of x value is also x only. So we can conclude f of g is equals to g of f. Okay, next he is asking to find f inverse and g inverse. So function f of x is given, for that inverse function. Function g of x is given, for that inverse function. Let us find. Okay, it's very easy to find the f inverse. First f of x, make it equals to y, which is equals to e power x. Now interchange these x and y. So in the place of y, x, e power, in the place of x, y. So now x is equals to e power y. Now we need to find the value of y. This is exponential form. We need to convert this to logarithmic form. So here x is there, write log for that, log x. Here base is e, write the same base e here also as the base is equals to alphabet x completed, alphabet e completed, then obviously remaining is y. So exponential form I converted to logarithmic form. So then y is equals to log x base e. Now this y is nothing but f inverse of x. F inverse of x value is log x base e. Next, g of x is equals to log x base e. So first g of x, make it equals to y. So y is equals to log x base e. Now interchange these two alphabets. In the place of y, x is equals to log, in the place of x, y base e. Now we want y value. So actually this is in the logarithmic form. We need to convert this logarithmic form to exponential form. It is very easy. Here write number x. Here base is e. This base you write as it is as a base only, is equals to x alphabet completed, e alphabet completed, so remaining is y. So e power x is equals to y. Logarithmic form I converted to exponential form. So y is nothing but f inverse of x. F inverse of x is equals to e power x. So we found the values of f inverse as well as g inverse. Oh, I'm sorry, here g, right? So this is g inverse of x. Okay, now let's move to the second question. Okay, the second bit is, if f of y is equals to y divided by under root 1 minus y square and g of y is equals to y divided by under root 1 plus y square, then show that f of g of y is equals to y. So he gave here f of g of y. This f of g of y is the same as f of g of y. So which is equals to f of, what is the value of g of y? He clearly mentioned it as y divided by under root 1 plus y square. So now in the question, f of y value is given as y by under root 1 minus y square. F of y value is this much. Then he is asking to find the value of f of y by under root 1 plus y square. So f of y by under root 1 plus y square is equals to, we need to find. So here simply in the place of y we need to substitute this total. So here y is there, in the place of y let us substitute this y divided by under root 1 plus y square whole divided by, here under root as it is 1 minus, here y square is there, again in the place of y we need to substitute it, y divided by under root 1 plus y square whole square. So now if we simplify it, we will get this numerator as it is, y divided by under root 1 plus y square whole divided by under root 1 minus. Now if we observe this, y divided by under root 1 plus y square whole square, it means this square is for numerator as well as for denominator also. So I am separating it, y square divided by under root 1 plus y square whole square. Here square root and square both will get cancelled. So we remains with numerator as it is, y divided by under root 1 plus y square whole divided by under root 1 minus y square by 1 plus y square. Now here this 1 plus y square we will multiply with 1. Now this 1 plus y square will multiply with 1. So numerator as it is, y divided by under root 1 plus y square whole divided by under root 1 plus y square into 1 plus y square minus y square whole divided by 1 plus y square. Here plus y square minus y square both will get cancelled. So numerator as it is, y divided by under root 1 plus y square whole divided by under root 1 by 1 plus y square. Now if you observe this denominator, this under root is for numerator as well as for denominator. So let us separate it. Numerator as it is, y divided by under root 1 plus y square whole divided by, this is root 1 divided by root 1 plus y square. Here root 1 plus y square, root 1 plus y square will get cancelled. So we remains with y by root 1. Root 1 is nothing but 1. So y by 1. Y by 1 is nothing but y. Then we got f of g of y is equals to y. Hence proved. Okay, the next bit is, if f is a function from R to R and g is a function from R to R, are defined by f of x is equals to 2x square plus 3 and g of x is equals to 3x minus 2. Then find f of g of x. So here f of g of x can be written as f of g of x is equals to f of g of x is given as 3x minus 2. Now we need to find the value of f of 3x minus 2. In the question he gave f of x is equals to 2x square plus 3. Now we want the value of f of 3x minus 2. So simply in the place of x we need to substitute 3x minus 2. So 2 of, in the place of x, 3x minus 2 whole square plus 3. So if we observe this, 2 as it is into 3x minus 2 whole square, it is in the form of a minus b whole square. So if we expand it, a minus b whole square is equals to a square minus 2ab plus b square. So 2 into 3x minus 2 whole square, if we expand, 3x whole square minus 2 into 3x into 2 plus 2 square. Here plus 3 as it is again. So we get 2 of 3x whole square, 9x square minus 2 3 is a 6, 6 2 is a 12x plus 2 square is 4 plus 3. Now here outside we have 2. I'll multiply every number which is there inside. 2 into 9x square, 18x square minus 2 into 12x, 24x plus 2 into 4, 8 plus 3 as it is again. So which is equals to 18x square minus 24x plus 8 plus 3, 11. So the value of f of g of x is 18x square minus 24x plus 11. Okay, the next question is, find the value of g of f of x. So here g of f of x can be written as g of f of x is equals to g of f of x value 2x square plus 3. Now we need to find the value of g of 2x square plus 3. Here g of x is given as 3x minus 2. Now we want the value of g of 2x square plus 3. So simply in the place of x we need to substitute 2x square plus 3. So here 3 into, in the place of x, 2x square plus 3 minus 2. So we get 3 into 2x square, 6x square plus 3 into 3, 9 minus 2, which is equals to 6x square plus 9 minus 2, 7. So the value of g of f of x is nothing but 6x square plus 7. Let's move to next question. Okay, the next question is f of 0. So f of 0. So first we need to find the value of f of 0. F of x is given as 2x square plus 3. Then f of 0 value how much? Simply in the place of x we need to substitute 0. So 2 of 0 square plus 3. Here 0 square is 0, 0 into 2 is 0. So 0 plus 3, it is 3. So now here f of 0 value we got as 3. So now again we need to find f of 3 value. So simply f of x is given as 2x square plus 3. Then we need to find f of 3 value. 2 into, in the place of x, 3 whole square plus 3. 3 square 9, 9 2 is 18 plus 3. So 18 plus 3 is nothing but 21. So f of 0 value is 21. Okay, the next question is g of f of 3. So this can be written as g of f of 3. So now first let us find f of 3 value. F of x is given as 2x square plus 3. Now we are finding f of 3 value. So 2 into, in the place of x, 3 square plus 3. So now if we find it, we will get 3 square is 9, 9 2 is 18, 18 plus 3, 21. So f of 3 value is 21. that I will substitute here. So we get g of f of 21. Now let us find f of 21 value. So f of 21 is equals to, here in the place of x we need to substitute 21. So 2 into 21 square plus 3, which is equals to 2 of 21 square, 441, plus 3, which is equals to 2 into 441, 882, plus 3, 882 plus 3, 885. Now this 885 I'll substitute here. So that is g of f of 21 value is 885. So now we need to find the value of g of 885. So g of x is given as 3x minus 2 and g of 885. So in the place of x we need to substitute 885. So 3 into, in the place of x, 885 minus 2. 3 into 885, 2655 minus 2, which is equals to 2653. Okay, the next bit is, if f is a function from R to R and g is a function from R to R are defined by f of x is equals to 3x minus 1 and g of x is equals to x square plus 1, then find the value of f of x square plus 1. So here f of x square plus 1. So f of, then what is the value of f of x square plus 1? So simply in the place of x we need to substitute x square plus 1. So 3 into, here in the place of x I am substituting x square plus 1. Here minus 1 as it is again. So now if we solve, 3 of 3 into x square, 3x square plus 3 into 1, 3 minus 1. So f of 3x square plus 3 minus 1 plus 2. Now we need to find the value of f of 3x square plus 2. So here f of x value is given as 3x minus 1 and we need to find the value of f of 3x square plus 2. So simply in the place of x we need to substitute this total. So we will get 3 of, in the place of x, 3x square plus 2 minus 1. So we get 3 into 3x square, 9x square plus 3 2s are 6 minus 1. So final answer is 9x square plus 6 minus 1, 5. So the value of f of x square plus 1 is 9x square plus 5. Okay, let's move to next question. Okay, the next question is, what is the value of f of g of 2? So here f of g of 2 can be written as f of g of 2. So f of, what is the value of g of 2? G of x is given as x square plus 1. So in the place of x we need to substitute 2. So 2 square plus 1. F of 2 square is 4 plus 1. So f of 5. Now f of x value is given as 3x minus 1, then we want f of 5. So f of 5 is equals to 3 of 5 minus 1. 3 5s are 15 minus 1, 15 minus 1, 14. So the value of f of g of 2 is equals to 14. Okay, the next question is, find the value of g of f of 2a minus 3. So that can be written as g of f of 2a minus 3. So actually f of x is equals to 3x minus 1. So in the place of x we need to substitute this total. So we get g of, here 3, in the place of x we need to substitute this 2a minus 3. So into 2a minus 3, here minus 1. So we get g of 3 into 2a, 6a minus 3 3s are 9 minus 1. So which is equals to g of 6a minus 9 minus 10, g of 6a minus 10 minus 10 minus 1. So g of x value is given as x square plus 1 and we need to find the value of g of 6a minus 10. So simply in the place of x we need to substitute 6a minus 10. So here x is there, 6a minus 10 whole square plus 1. Now this is in the form of a minus b whole square. So if we expand, a square plus b square minus 2 into a into b. here plus 1 as it is. 6a whole square 36a square plus 10 square 100 minus 2 6 are 12, 12 10s are 120a plus 1. So the value of g of f of 2a minus 3 is 36a square plus 100 minus 120a plus 1. Here two numbers are there, so if we add those we will get 36a square minus 120a, 100 plus 1 101. Okay, the next question is, if f of x is equals to 1 by x, g of x is equals to root x, for all x belongs to 0 to infinity, then find g of f of x. So g of f of x. G of f of x is nothing but 1 by x. So here g of x is equals to root x, then we want the value of g of 1 by x. So simply in the place of x we need to substitute 1 by x. So we get root here in the place of x 1 by x. Here this root is for numerator as well as for denominator, so if we separate we will get it as root 1 divided by root x. Root 1 is nothing but 1 divided by root x. So the value of g of f of x is 1 by root x. The next question is, if f of x is equals to 2x minus 1, g of x is equals to x plus 1 by 2, for all x belongs to R, find g of f of x. G of f of x is equals to g of f of x value is given as 2x minus 1. So here g of x is equals to x plus 1 by 2, then we want the value of g of 2x minus 1. Simply in the place of x we need to substitute 2x minus 1, so which is equals to, here x is there, so 2x minus 1 plus 1 as it is, whole divided by 2. Minus 1 plus 1 both will get cancelled, so which will remains with 2x divided by 2. 2 cancel, so we get x. Then the value of g of f of x is nothing but x. Question number 7. If f of x is equals to 2, g of x equals to x square, and one more extra function is there, h of x is 2x. For all x belongs to R, then find the value of f of g of h of x. That also can be written as f of g of h of x. So first, in the place of h of x, what they give the function, I am substituting that f of g of h of x is nothing but 2x. Now f of g of 2x value, g of x is nothing but x square, so in the place of x we need to substitute 2x. So here x square is there, then it will be 2x whole square. So we will get f of 2x whole square 4x square. Here if we observe f of x value is given as 2, then he is asking to find the value of f of 4x square. Observe this clearly, f of x value is 2. So here any number you substitute in the place of x, always the answer is some fixed number 2 only. So that's why f of 4x square value also 2 only. Here f of x is equals to 2. It is a constant function, so whatever the number we substitute in the place of x, definitely we will get the answer 2 only. So here 4x square we are substituting, so definitely answer is 2 only again. So the value of f of g of h of x is equals to 2. Okay, the 8th bit is finding the inverses. The first question is given as a comma b belongs to real numbers. F is a function from R to R defined by f of x is equals to ax plus b. So first f of x, make it equals to y. So y is equals to ax plus b. Now interchange the alphabets. X is equals to ay plus b. Now bring an equation for y. Take plus b to the left side, will become minus b. X minus b is equals to ay. Now we want an equation for y, so take a also to the left side. X minus b whole divided by a is equals to y. Now this y replace with f inverse x. So f inverse of x is equals to x minus b whole divided by a. This is the inverse of the given function f of x. Next question is, f is a function from R to 0 comma infinity defined by f of x is equals to y 5 power x. So y is equals to 5 power x. Interchange the alphabets. X is equals to 5 power y. Now this is exponential form, so let us convert this to logarithmic form. For the x, keep log x. Here base is 5, here also write it as base only, is equals to y. So now in the place of y, replace with f inverse of x. F inverse of x is equals to log x base 5. This is the inverse of the given function f of x. The next question is, f is a function from 0 to infinity to r defined by f of x is equals to log x base 2. So y is equals to log x base 2. Now the given function or equation here, it is in logarithmic form. We need to convert this to exponential form. Here write y as it is. Here base is the 2. Here also write that as the base only, equals to remaining number x. So 2 power y is equals to x. Oh sorry, I didn't interchange the alphabets. Here interchange the alphabets first. X is equals to log y base 2. Now for this x, apply log x. Here base, oh sorry, this is an exponent, sorry, logarithmic form. We need to convert this to exponential form. So x as it is. Here base 2, so write it as base 2 is equals to y. So 2 power x is equals to y. Now in the place of y, write f inverse of x. F inverse of x is equals to 2 power x. This is the inverse of the given function. Question number 9 is, if f of x is equals to 1 plus x square plus x cube and so on for mod x less than 1, show that f inverse of x is equals to x minus 1 divided by x. So here f of x is given as 1 plus x square plus x cube plus x power 4 and so on. F of x is equals to this first term 1 as it is. Now in the second term, third term, fourth term, fifth term and so on, if we observe, in every term x is there. So I am taking x common. Here x is there, I took x, so remains with 1 plus here x square is there, here x, so remains with 1 more x. Here x cube, here x, so remains with x square. Here x power 4, here x, so remains with x power 3 plus and so on. So f of x is equals to 1 plus x into, if we observe this total which is there inside the bracket, 1 plus x square plus x cube plus x power 4 and so on, it is nothing but the question itself, because in the question he gave f of x is equals to 1 plus x square and so on. So in the place of this I will substitute f of x. Now this second term total x into f of x I will take to the left side, so we will get f of x, this plus is there, so it will become minus x into f of x is equals to 1. Now in this first term f of x is there, in the second term also f of x is there, so I am taking f of x common. So what will remains with f of x if you take common? Here 1 minus x is equals to 1. So now f of x is equals to this 1 minus x I will take to the right side, so we remains with 1 by 1 minus x. So this is the original function he gave in the question. Now let us convert, find the inverse. Make it equals to y. So y is equals to 1 by 1 minus x. Interchange the alphabets. X is equals to 1 by 1 minus y. This total denominator I will take to the left side, so we will get x into 1 minus y is equals to 1. So x into 1 x minus x into y xy is equals to 1. Now I will take this minus xy to the right side and bring 1 to the left side, so we get x minus 1 is equals to xy. Now we want an equation for y, so y is equals to x minus 1 divided by x. Here y is nothing but f inverse of x. So f inverse of x is equals to x minus 1 divided by x. F inverse of x is equals to x minus 1 by x. F inverse of x is equals to x minus 1 by x. So hence proved. Okay, the next question is, if f is a function from 1 comma infinity to 1 comma infinity defined by f of x is equals to 2 power x of x minus 1, then find f inverse. He gave one function, we need to find the inverse of it. So f of x is equals to 2 power x of x minus 1. F of x, make it equals to y. So y is equals to 2 of x into x square minus x into 1 x. Now interchanging the alphabets, x is equals to 2 power y square minus y. Now this is exponential form. I will convert this to logarithmic form. So here x is there, keep log x. Here it is base 2, right here also as base only, is equals to y square minus y. Now everything I will take to one side, so we will get y square minus y. This log x base 2 will become minus log x base 2 is equals to 0. Now if we observe this clearly, it is a quadratic equation. So we need to find the zeros of it. So splitting middle term is difficult, so that's why I'm going with the formula. Minus b plus or minus under root b square minus 4ac whole divided by 2a. Here what is the b value? Minus 1. So minus of minus 1 plus or minus under root b square minus 1 whole square minus 4 into a value y square coefficient 1 into c value minus log x base 2 whole divided by 2 into a value 1. This minus of minus plus 1 plus or minus under root minus 1 square 1. This minus of minus plus 4 into 1 4 into log x base 2 4 log x base 2 whole divided by 2 into 1 2. So this is nothing but f inverse of x. Okay, till now if you didn't subscribe to my channel, subscribe for more videos. Thank you.